And let's talk chemistry with Pastor Dan. We are going to look at titration today. Before we do that, though, let's do a quick review of pH. So I want you to stop the video, try this. I want you to find the pH of 1.225 times 10 to the minus 6 molar sodium hydroxide. Remember, hydroxide is a base, so we're going to have to find the hydroxide ion, then the POH, then the pH. So pause it, give it a shot. Okay, you should have got a pH of 8.088. It's slightly basic. Hydroxide is a base. All right, so what are we looking at today? We're looking at titration. Titration is defined as a process to determine the concentration of a substance by neutralizing it with a second substance of known concentration. So here we go. Here's the setup. This item right here is this. It's referred to as as a burette. Now inside of that, we're going to put the concentration. For your lab, you're going to use your base concentration. This little flask here we're going to use is called an Erlenmeyer flask. It's fluted at the top so that things can't splash out as in. Inside of there, we're going to put the known unknown concentration defined. And then lastly, we're looking for a color change to occur. Now, we're going to want a pinkish color. If it goes red, it's too far. So the lab you're going to set up is going to try to get it within 0.5 milliliters. Let's show an example. This is the actual lab that you're going to do for the formal lab. We'll discuss the formal lab in the next video. So let's start with the reaction. The reaction is hydrogen plus sodium hydroxide forms sodium chloride plus water. It's already balanced. We're always going to start with the concentration. We have two volumes, which when we start with, we're going to start with the concentration we know. Well, it says 0.500 molar sodium hydroxide, so that's the volume. So we're going to put that over 1. Now, we need it in liters. We're not using molar volume because this is not a gas. These are solutions. So we'll put it in liters, and we're going to use that concentration. So if it's 0.500 molar, that means it's 0.500 moles over 1 liter. Just slide that right up inside of there. And then using our stoichiometry, go back and look at, we're going to have hydrochloric acid and sodium hydroxide. That's a 1-to-1 relationship. We multiply that through, and we multiply through using your handy dandy Joe Dandy calculators, 23.33 times 0.500 equal divide by 1,000. You should get 0.117 moles. Now that's only half of the problem because I want concentration. Remember, concentration is molarity. So I'm going to have to convert this to liters. 1 liter is 1,000 milliliters. Plug that underneath there. We divide it through. We get 1.17 molar HCl. All right, let's try another one. This time determine the concentration of 20.0 milliliters of copper 2 hydroxide if it's titrated with 0.7556 molar nitric acid starting at 5.00 milliliters and ending at 31.65 milliliters. All right, so there's our reaction, okay? Double replacement reaction, and balancing it up looks like that. All right, so I've got 3 volumes. Which one do I do? Well, we're using the burette again, and the concentration is right here, so it's going to be these two. What we're going to do is we're going to subtract them. So it starts at, ends at. The difference between those gives us the volume we're going to use to titrate that, and that goes over 1. Again, we're going to go to liters. So 1 liter is 1,000 milliliters. Using the concentration, moles per liter. And then from our balanced equation, we know that 2 moles of nitric acid is 1 mole. So take your calculator, take 26.65 times 0.7556 equal, divide by 1,000, equal, divide by 2, equal, check our sig figs. I've got 4. The other values are infinite. You should get 0.01007 moles of copper 2 hydroxide. Now, again, we need to take my volume here of my base and convert that into liters. So we get 0.5035 molar copper 2 hydroxide. All right, let's try this one now. Stop it, then we'll work through this one. See if you come up with it. Give it a shot. Okay, for practice. Here we go. So there's our balanced equation, not balanced. So there we go. We have there. We're going to use subtraction of the difference because that's the concentration we know. We then take the concentration, the molar relationship, get 0.06858 moles over 0.01500 liters. We get 4.573 molar sulfuric acid. Let's try one more just for kicks and giggles. Pause the video. I'm not going to show you the work. I'll just give you the answer. See what we come up with. Answer is right there. Hopefully that wasn't too bad. Take care. God bless. We will talk about that formal titration lab tomorrow. All right. Take care. God bless.